two types of distribution. Okay, when I talk about distribution, last lesson I have explained what is a distribution. A distribution is talk about a various value of x, like x can take 0, 1, 2, 3. For example, I'm toasting the coin for 3 times, and I say the number of heads achieved, use capital X to represent that. That's the random variable, and that's a discrete random variable. And then the distribution means you need to list out the probability clearly. So the probability you can find is 1 on 8, 3 on 8, 3 on 8, and 1 on 8. Okay, that's a probability distribution. How do I find 1 on 8, 3 on 8? Those values is by using tree diagram. I sketch a tree diagram and I find that out by tree diagram. Okay, also it can be shown by a graph. Okay, you can see this graph here. We can show the same information just on a dot graph. Or the last way we have it is a probability function. It gives you some function and then it says x can take a couple of values, and then this function represents the probability for that particular value, and then you can work out for each of them back to a table method. Get back to a table method. And we have 2 requirements for probability distribution. The first one is all the values needs to be in between 0 to 1. Well, for any probability, not only probability tables, it needs to be in between 0 to 1. Second, the sum of all the probability needs to give you 1. Okay, because that represents every single case. Add up will give you 1. Shh. Okay, let's come back to this part. What we have is the type of distribution arising from sampling without replacement. Okay, I just want you to highlight this part, without replacement. You are dealing with something without replacement. And this kind of selection, okay, you basically, what is a without replacement case? This is a group of 25 students in this classroom. I'm grabbing 3 to attend a math competition. That's a without replacement case, okay? I'm grabbing 1, grabbing another one, and grabbing another one, but you're not going to have one and replace back and have another one, okay? So this is a without replacement selection. This kind of selection we'll call a hypergeometry distribution. Well, you don't really need to remember the name, but I just want you to know the name. So for other special distribution, just give you some interesting results for this distribution. In your calculator, okay, if you go 5 and 5, you can see that's called a normal distribution. This is called a T distribution, and this is a chi-square distribution, binomial distribution, okay, F distribution, geometric distribution, Poisson distribution. Okay, that's what I learned in uni. Well, you learn 3 basically. So which 3 you will learn in high school? You will learn normal in year 12, you will learn binomial in year 12. But the third one we learn is called a hypergeometry, but actually that's the first one we learned. Okay, hypergeometry distribution, but it's not in the calculator. All the other distribution you do can use calculator to help you to evaluate. Only hypergeometry distribution, there's no ways you put in calculator and calculate. You must be a hand approach. Okay, the formula you must remember it by yourself, and it's not going to, even though it's a section 2, you can't do this by calculator, because that is a special distribution that does follow some rules, but just the calculator is too complex for the calculator to put the results in. So you're not going to have this on your calculator, but it is a special distribution called hypergeometry distribution. So we can use 2 methods. Okay, one method is the tree diagram, but I'm not going to recommend you to do that. If it's 3 selections, it can be extremely complex. The second one is combination method. Okay, combination method is, remember when I say 5 males, 7 females, I'm selecting 1 male and 2 females. Okay, we select 1 from the 5, select 2 from the 7, and over the total is 12, 3 out of 12. So that's how we do that when we do chapter 10D. Okay, that's what we do for chapter 10D. We are doing exactly same thing in this question. Okay, let's have a look at example 1. Okay, it can be a lot of writing here. Okay, the first question will be a lot of writing. So 3 students from class of 10 girls and 15 boys are selected to form a team to participate in the math game day. Okay, let G be the number of girls in the team. Okay, can you let me know what G could be? How many students you select? Okay, 3 in a team. What G could be if G represents the number of girls in the team? 0, 1, 2, 3. Okay, never forget 0. So G is actually 0, 1, 2, 3. Let's set up the table. Like, remember the table we have before? We need to set up that table with 2 rows. Lowercase g, probability capital G equals to lowercase g. Have 0, have 1, have 2, and have 3. Okay, that will be the probability distribution. Okay, that will be the table. Gives you what values you have. Okay, what values you have for probability to get 0 girl. Now I want to find a probability to get 0 girl. Okay, when G equals to 0. Okay, this is represent outcomes in numbers. If we represent outcomes in words, that will be no girl and 3 boys. Okay, tell you the number of girls, you must know the number of boys as well. So I want to find this probability. I want to find the probability that G equals to 0, which means I want to find the probability that there's no girl and 3 boys in the team. This is the events I have interest. Okay, so what I will do is 10, I will select 0 from 10. I will select 3 from the 15. The total, okay, remember the total. The total will be select 3 from the 25. Okay, select the 3 from the 25. That will be the probability that the G equals to 0. Okay, G equals to 0. Okay, next thing I want to ask is, what's 10 0 equals to? This number here. 1. That's 1. So I can just cross that out. That's just a 1. So what I have is a 15 3 and a 25 3. Okay, so if I want to expand that, what 15 3 equals to? What's the formula? NCR formula. N factorial? Okay, over or over R factorial, so that's 3 factorial and 12 factorial. Okay, that's the numerator. And what's the denominator? Divide by, okay, denominator is divide by a 25 factorial, a 3 factorial, and a 22 factorial. Okay, so 15 factorial over 3 factorial and 12 factorial times 3 factorial, 22 factorial, and 25 factorial. So the 3 and 3 will get crossed out, and 15 and 12 factorial. Okay, 12 can go, so 15, 14, and times 13, and times the 12 factorial, so they just cancel each other. For 22, so what I'll have bottom is 25 times 24 times a 23. Okay, then I have 15 and 25. I can divide 5 on that. I have 3. Divide the 5 here, that's a 5. And the 3 can go further, cancelled with this 24. I have 8 here. Yeah, this 8 can divide by 2, got 4. This 14 divided by 2, got 7. Well, I think that's it. The top is 7 times 13. The bottom is 5 times 4 times 23. Well, I'm not sure if I calculated this correct or not, to be honest. I think it's correct if I'm not doing anything silly, but I need to check that in the calculator. Menu 5, okay, combination is 3. So what you do is 15, comma 3, and then divide by menu 5, 3. Oh, really?
Yeah.
Oh, great. Yay! Get it. Very exciting. Well, you shouldn't do this by hand. I just want you to practice the formula once, okay? We'll do calculator approach later. But when g equals to 0, the probability of getting that is 91 on 460. That's the probability, okay? That's the probability. I'll just show you another example, okay? Just show you another example. So I want to know g equals to 1, which means there's one girl. How many boys I need? Okay, 2 boys. So the probability that g equals to 1 will be, you have 10 girls, you want to select 1. You have 15 boys, you want to select 2. And the denominator is still a 25, 3. What's 10, 1 equals to? 10, 1 is a 10, so that one will change to a 10. Okay, so have I have a quick calculator out. I just copy this down. And this 10 times this one becomes a 2, right? Yeah. Enter, that's a 21 on 46. Okay, that's a 21 on 46. So this is the probability, 21 over 46. That's the probability to get one girl in this team. Okay, that's the probability of getting one girl in this team. Okay, I give you 5, not 5, it's too long, 2 minutes, okay, 1 minute for each to calculate those 2 out for me. Okay, exactly following the same method. Calculator?
Oh, okay.
Okay, I give you 2 minutes, okay? Okay. So g equals to 1, that's this, and if we have g equals to 2, we need 2 girls and 1 boy. So therefore, the notation we'll have is probability that g equals to 2 equals to 10 select 2, and then 15 only select 1, over 25 select 3. Okay, tell me, what is 15, 1? 15? 15, 1 is 15. So therefore, okay, that changed to 15, and that needs to be a 10 because, oh, that's a 110. That's a 10. Okay, I need to select 10 from the 2 from the 10 girls and 1 from the 15 boys. But 15 1 is a 15, and then we denominate 25 and 3. We have 27 over 92. Okay, 27 over 92. Okay, and the last one is when g equals to 3. So probability that g equals to 3 equals to select 3 from 10, select nothing from 15, but select 3 from 25 again. 15 0 is 1. It's not 15, okay, it's 1. So you don't have that. So what I will have, it's easier to copy that down, and I have 10 here. There's 6 on 115. Okay, 6 on 115. Alright, so I'll just put this in 6R115. Okay, this table, okay, ignore what we all write besides that. Just that table is your final answer. This is called the discrete probability distribution for G. Okay, that is the distribution for G. How it distributes among the values 0, 1, 2, 3. Okay, what probabilities you have for each of that values. Okay, that table is the answer. That is the probability distribution. Okay. So now what we have is that we have 4 values and you got 4 probabilities. If you add those 4 probabilities, what you should have? 1. If that's a distribution table, therefore it must add up everything gives you 1. Okay, give you 1. Otherwise it can't become a distribution probability distribution. Okay, let's have a look at the questions asking before. The probability that the team contains at least 2 boys. Okay, we are talking about girls in this question, right? We are not talking about boys. And the random variable you have is G, not a B, okay? So it's a G. You are talking about girls. If I say at least 2 boys, what that means for girls? So how you can say that in words? At most 1 girl, right? At most 1 girl, like in this team. So what I can do is, well, be careful with your notation. You need to start to learn how to write notations now. You can't just like, oh, I know the value, I put the values in, that's it. You need to think about how you can talk about the notation. The notation is PR contains, like as I said, at most 1 girl. Okay, at most 1 girl. G is less than or equals to 1. That should be your notation. Instead of talking about boys, we need to talk about girls because that G is the random variable given to us, okay, in the original question. So we need to find G less than or equals to 1. So what do you think the probability will be? Yep. That's probability G equals to 0 plus probability G equals to 1. So either 0 or 1. So it's a plus in between. So 91 over 460 plus 21 over 46. Again, 210, 301 over 460. Correct? Check. Just don't. What I feel is I don't care. You said what? I believe that. Don't believe me, okay? Yeah. Okay. Good. Good. Well, because I'm very sad this morning, I'm trying to do year 12 trial exam with them together, and I feel like I can still do all of it. It's just the accuracy is not very good because I'm not practicing anymore, okay? So you need to keep practicing math questions. Even though I know exactly each question how to do them, I still find problems with my calculations or that kind of thing. So practice is very important. Even I have practiced for like 20 years. Still, like if you stop that, you forget, okay? Next one. The probability that the team contains 2 girls, given that at least 1 girl is selected. Okay, what the notation can be? Like, start from the beginning. P, R, you're talking about probability. What I have at the G. Well, first, what do you need? Yeah, G equals to 2 and given less greater or equals to 1. Okay, at least 1, so it's 1 or more. So G is greater or equals to 1. So not only you can do the question, you also need to give out the notation, the expression correct. Why I just want you to write expression? Because in year 12, a lot of questions, even though you don't know how to do it, after you write this step out, you can start to do it, even though you don't understand it. Okay, so after you write the notation, okay, what a given, how you can find a given? You find intersections and you divide it, even though you don't understand the question at all. Okay, so just some tips for you to get marks. Okay, so if you can write this and, well, to teach you, definitely I shouldn't teach you in that way. Okay, I shouldn't teach you to say, oh, even though you don't understand, you can still do it. But like, in real, like you can. Okay, that's what you do. So, well, I find my year 12s, even though now they don't understand probability perfectly, they can all do questions in probability now. They just remember how to do them. And, okay, that's the given question. And we find intersections and we divide it back and that's it. Okay, well, they don't understand at all what given means. That's the wrong way for education, but, well, okay. Okay, what's the intersection between those two sets? What's the intersection between those two events? Well, you need to find the intersection between them, right? G equals to 2. Because when it says G greater or equals to 1, it's 1, 2, and 3. And then G equals to 2, that's equals to 2. The intersection is just G equals to 2. And, okay, G greater or equals to 1, that can be 1, 2, and 3. So you exclude what? 0. So you can go 1 minus probability G equals to 0. You rather subtract one thing compared to adding 3 things together. Okay, so that's what you would do. So what is G2? Let's have a look. G2 is 27 on 92. Divide by 1 minus G0. Okay, G0 is 91 over 460. 1 minus 91 over 460. 27 over 92 times 460 over, okay, you subtract that, that's a 963. I think that will be the answer. And then you trying to simplify that. That's a, well, I'll write here. That's the subtraction is that, and you flip it, that gives you that. And 460 divided by 92 is a 5. You can have a look, and you can divide that by 9. That gets a 3. You can divide that by 9. That's a 41. So 15 on 41 will be the answer. Okay. Everyone understand? Okay, so after you find out the distribution table, everything is easy to deal with. It's because it's back to year 10 stuff. Okay, back to year 10 stuff. You just look at values in the table, and then, well, most important thing is how you can set up this table. That's what we all need to know for this exercise. I would like to start a little bit for the next exercise because I don't think I have enough time tomorrow. So I will just go through the definition bit with you, and also it's combined well with this exercise. So we have 2 ways to select things. Okay, we can select with replacement or we can select without replacement. Okay, what we learned that is without replacement. Okay, we just select and then not putting back. This exercise is called with replacement. Okay, sampling with replacement. What's the name for the previous distribution? That's a hypergeometry distribution. And for this one, with replacement, this is called a binomial distribution. Okay, binomial distribution. 2 distributions, what we learn. One is called hypergeometry, the other one is called binomial. Binomial is with replacement, and hypergeometry is without replacement. All right. Let's have a look at this one. Why we are doing this? Okay, why we are doing this? First of all, I'm explaining that. So toss a coin for 3 times. What's the probability of obtaining 2 heads? Okay, tell me what method you use to find this question. You are not tossing it by yourself, okay? I am asking the theoretical probability, what that could be. Tree, okay, tree diagram, yes, or any? Well, you can't do 2-way table by 3 trials. Well, you can't really do by other ways unless you can directly think about it. Okay, you can think about it. Well, you can list it. It's head, tail, head. Head, head, tail. Or tail, head, head. There are 3 situations. And each of that is a 1/8 probability to get each of that. So that's another way we can do it. Okay, that's by, let's say, tree diagram. Or like listing the outcomes. Okay, listing outcomes. That's the 2 way we can do it. Let's have a look at case 2. Tossing a coin for 100 times. What's the probability of obtaining 20 heads? What you can do? If you tell me tree again, yes, you can do by tree diagram, but the outcomes will be 2 to the power of 20, and then you count them one by one. That, oh no, 2 to the power of 100 actually, and then you find where you get the like 20 heads. There's no way we can do it, okay, by what we learn at the moment. Tree diagram is helpful, yes, it can do 90% of the question, but when the trials get too big, okay, too many trials, we can't use tree diagram, it's not realistic, okay, just can't work it out. You need a paper maybe this size and then listing the outcomes, or even bigger. So you can't do that. Therefore, we introduce binomial distribution. Because think about toss the coin. Your probability of every time is not changing, right? Any toss is not changing. So it will be the same for the whole experiment. So this is called a binomial experiment. Is one that processes the following properties. Okay, we have the following properties. What we have? The experiment consists of a number of identical trials. Okay, label the word identical. It must be exactly the same. That's why we can't do without replacement. Think about the candy. Okay, 10 red, 10 green. I take one without replacement. The probability change after the first trial. Okay, so the probability needs to stay the same for each trial you start with. Therefore, we need to replace the thing we select at the first trial. Okay, that's identical trials. For toss the coin, we have number of trials equals to 100. That's our number of trials. Okay, I'm doing something, repeating how many times? 100 times. Second, each trial results in one of 2 outcomes, which are usually designed as either a success or a failure. For toss the coin, I can say get a head is a success, getting a tail is a failure, right? Like, well, even though there are 3 color candies in this box, okay? It's 3 color candies in this box, okay? Red, orange, and yellow. Girls. Red, yellow, and orange. Okay, 3 color candies. That's 3 outcomes. But what I'm interested in, for example, I'm interested in the red candy. Okay, I'm interested in the red candy. So red candy can be a success. All the other 2 colors can be counted as a failure. So they can be one thing. I don't care which failure I get. They just can in total become a failure. And that one's a success. So not necessarily say there's only really 2 outcomes. There can be more. But if you're only interested in one, then the others can become the failure, and that one become the success. Okay, just as the candy questions explained. 3 is the probability of success on each trial is P. Okay, success on each trial is P. So toss the coin. I toss it each time. It's got a successful rate half, 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 half. P is a half. Or say there's 10 red candy, 20 other color candy, then the successful rate is 1 on 3. Okay, the successful rate on each trial is 1 on 3 if you replace that back. So 1 on 3, 1 on 3. So then the failure rate must be 1 minus P. So they add together should give you 1. Either success or not success, they add together should give you 1. And then the trials are independent. Okay, what independent means is just with replacement. Okay, just like again tells you they are with replacement. Why they are independent? They are not influencing each other. Okay, the first one's outcomes are not going to influence the next trial's outcome. So I grab the candy, I put it back. That will still be the same box of candy, and I do another time. Each trial will be independent. I toss the coin. Okay, after I toss the head, it's not going to have more or less chance to getting head. So still the same for half for the next trial. So this is really just tells you need to replace the thing back. Well, say 10 red, 20 others. If I grab a red one out and I'm not replacing it back, the next trial will rely on what you have at the first trial. Then that's a dependent experiment. It's not independent experiment. So this is like independent. Okay, not affecting the outcomes of the previous trial. Okay, now come to the really important thing. That's all the thing, like what kind of experiment can become a binomial distribution. So these are the kind of like requirement we need. And then what is the distribution? The random variable of interest, we use x. For example, this x can be number of heads in my current question. Okay, number of heads I get. So x is the number of heads I get from 100 toes. Well, what x can be? X could be 0, 1, 2, 3, 4 until 100, right? I can toss it 100 times, get no head, like really unlucky, but possible. Okay, one head, well, not really like easy to get, but possible. And also like I toss 100 heads, not that possible, but it's still possible. Okay, so very unlikely, it's still possible. So x is the number of heads I could get from 100 toes. So that's 0 to 100. We can take all those 101 values. Okay, so this is and in the n trials is 100. Okay, in this case, n is 100, and of a binomial experiment, and we have proof that tossing coins 100 times is a binomial distribution. So I repeat it 100 times. Each time the probability of success will be the same, and each trial will be independent. So it satisfies all those 3 requirements. Therefore, it is a binomial distribution. Thus, x has a binomial distribution and has rule like that. Okay, important thing. This is the notation. What kind of notation is that? First of all, for example, this toasting coin question, I will say let x be the number of heads obtained from 100 toes. Okay, and then the next line you need to say x is binomial distribution. Okay, you know that, I don't know. Okay, for example, I'm just a marker, like not knowing any math, so you need to tell me what is it, you are following what rule you are doing. So x, like squiggly line, and then you say that's a binomial distribution. The bi means that's a binomial distribution. And 2 things will change the probability. One thing is how many trials you are doing. Okay, how many trials you're doing? This question, 100. Okay, that's the first thing will influence the probability. Okay, so the probability will be different. You toss the coin 10 times, you want 10 heads. And you toss it 100 times and you want 10 heads. Okay, that will be different probability. So the n will influence the probability. The second parameter will be the probability successful rate. That's just half in this question. Again, it will be the different. Say I want 10 heads. If it's a bias coin, I have the probability of getting heads is a quarter. And I have a fair coin, I have a half to get a head. Sure, the probability will be different to find 10 heads if you toss it for 100 times. Okay, so that will be different. So this is just the notation, says that what your x follows. And your x in this case can be 0, 1, 2, dot, 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 100. Okay, that's the possible x you can take for this question. And then, very important, that's to find the individual probabilities. So what we're trying to find, do you remember what I'm asking? 20 has. So what you want to find is probability x equals to 20. But why I say this is helpful? Because we have a formula directly can apply to it if that's a binomial distribution. Okay, if that's a binomial distribution, we have a formula directly can apply to it. That is the formula. That is the formula. So what this formula is talking about, okay, what that equals to? That equals to 100. N is 100. Lowercase x is 20, is the value you want in this trial, okay, 20. And p to the power of x, what's p? P is a half to the power of 20. And then 1 minus p is 1 minus a half. N minus x is 100 minus 20. That's the probability, okay? If you can evaluate that, that will be the probability of getting 20 heads when you toss the coin for 100 times. Well, if you want 1, then it's 100, 1. Half, 1. A half, 100 minus 1. Okay, so you can just use this formula. You don't need to draw tree diagram. You don't need to think about outcomes. So, this is the formula you must remember. Okay, first of all, that something needs to remember. Okay, number 1 is you need to define the random variable by yourself. So you can't just start to use the x when the question is not given to you. You can't just say, oh, x is a binomial. What is x? Okay, you need to clearly state what is x. Second, you need to clearly state what is the distribution for x. Okay, x is a binomial distribution. So you need to say x is binomial with what 2 parameters you have, n and p. Okay, n comma p. Number 3 is this formula. Okay, you need to remember this formula. This formula is just here. Okay, if it follows binomial distribution, what kind of thing you can find? Okay, how you can find the probability for specific values you're interested in. Okay, that's number 3. But what I want to say is, can you have a look at this answer here? That can be a really huge value. Do you agree? You are not very likely to evaluate that by hand. What you have on the denominator for this part is 2 to the power of 100. Can you really evaluate 2 to the power of 100? No. So, number 4 is how to use it on CAS. Well, not really type that in. If you type this formula in, it's waste of time. As I show you the place for distributions, there's a function directly you can use to find the value. So where is it? Is here. Menu number 5, probability. Number 5, distribution. Okay. Be careful. On your calculator, the order will be different from mine because I just upgrade my software, so that will be different. Mine is in number 5, and A. Okay, binomial PDF. Your may be at D, 55D. Okay, for dog D. I think yours there. Okay, we will use B as well. Yours is at E. Okay, A, B, C, D, E. Yours at E. So my A, B is the same as your D and E. You are looking for the function binomial. Okay, binomial PDF and CDF. So I'll just quickly go through what is binomial and CDF for you. PDF is you looking for single values, like what we're trying to find now. So I want a 20. I want a 30. CDF is the continuous values. For example, I want x greater than 4. So it can be 4, 3, 5, 6, 7, 8, 9, 10 until 100. So you want a group of values. Okay, it's continuous list of values. So greater than something or less than something, not only one, like 1, 2 or more. Okay, 2 or more. So in this case, we need a PDF. So you put N and P in. So N is 100 and P is 0.5. And the X value, what do you want? in this case, you want 20. Again, 20 head. Directly press OK because the answer, like the formula is installed inside. And also that's e to the power of negative 10. You have a really small number, 0.0000000004228. That's e to the power of 10. Here, see at the back. So that's 10 to the power of negative 10. Really small number. But I'll just let you know how you find it. You can directly use calculator to find it. But don't think you have calculator, everything is fine, because you will have part 1 exam and then you can't use calculators for that. Okay, you can't use calculator. So this formula is very important. You must remember that. Okay, you must remember that. Okay, I will stop here for today, but what I want you to do is try example 1. I will go through example 1 with you tomorrow, but try example 1 for now. Well, if you have no problem, you can just go to, well, you can't go 3 and 4, so just try example 1. Okay, just try example 1.